Saw dudes. How's it going? It was great seeing everybody yesterday. I miss you all so much. Um, Day 13.5, complex and mixed expressions. Today's lesson is actually really short. As you can see, it's not even a full page. So, want me to do that again? Yep, not even full page. See, I told you. This is, again, where we are talking about fractions, but complicated rational expressions. And today we're going to apply another aspect of fraction living to our rational expressions. We're doing improper fractions. And I just heard all of you go, oh no! I promise you it's not going to be that bad. I don't know why that just made me laugh so hard. Okay, so we remember 3 1/4. Well, this is an improper fraction because it has the whole number and the fraction. But if we want to get it all as a mixed fraction or a mixed number, or I'm sorry, this is a mixed number because it's the number and the fraction, but we want an improper fraction, meaning that the numerator is larger than the denominator. How we undo the mixed number is we multiply denominator by the whole number and then add it to the top. So 4 times 3 is 12, plus 1 is 13. Or if we have this guy, again, we're going to multiply the denominator by the whole number. 5 times 4 is 20, plus 2 is 22. So a lot of this kind of stuff, it's the same basic format with all of these mixed numbers, etc., etc., etc. So let's just look at it. So whole numbers as fractions. So also, right, more review. The number 4, well, any whole number, whether it's just the number or variable or la 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 la, is over the number 1. So 4 is the same as 4 over 1, and 6x is the same as 6x over 1. We're going to see a couple of these examples when we try to add and subtract rational numbers. So let's say this is our first example. We have 4y plus 3 over y minus 2. Okay. Well, what this is going to look like is first we need common denominators. Yes, we still need to do that. So I'm going to make this 4 over 1. Now, in this case, our least common multiple, right? The common denominator, our least common multiple, is this guy over here, y minus 2. So in order to combine these, I need to multiply this guy by our least common multiple, top and bottom. Okay, so that's going to give me this 4 times y minus 2 over 1 times y minus 2 plus 3 over y minus 2. And so if we multiply that out, 4y times y is 4y squared minus 4y times 2. So 4y squared minus 8y plus 3, right? Because we're adding that all over y minus 2. And now what we should do is we should factor this to see if we can, or to show that it is simplified. So again, 4 times 3 is 12 minus 8. So that's going to be negative 6 and negative 2. That's awful. And of course I don't have enough space for this whole example. What if I did it like this? 4y squared minus 2y minus 6y plus 3. So this is going to be 2y 2y, 2, and then it'll be 2y minus 1. And this is going to be, wait a second. Why am I doing this like that? Oh, because it's supposed to be plus 3 dork. Okay. And then I'm going to pull out negative 3, 2y minus 1. So then it would actually be 2y minus 3, 2y minus 1 over y minus 2. That's the actual simplified form. But anyway, okay, so moving on. Moving on. What does this mean? And this is something that you'll see way more frequently as we move on. Now, if you notice, there are 2 fractions within a fraction. There are 3 fractions involved here. Elena, don't give up. Don't lose heart. This is actually going to be a lot easier than it looks like. What I'm going to do is I'm going to use this middle fraction, if you will, this larger one, this fraction separating the smaller fractions. And I'm just going to rewrite that as a division sign. So I've got the top fraction divided by the bottom fraction. Well, how do we divide fractions? Keep, change, flip. So I'm going to keep that, change that, and flip that. Then I'm going to simplify and end up with 2/3. So, not if, but when you see weird little fraction things like this is what you do. Okay. So here's what it's going to look like. Oh yeah. Okay. So we have x divided by y, x over y divided by 4. So fraction. Again, I'm going to use this bottom one as my division sign. X over y divided by 4 over 1. And again, keep, change, flip. So that'll be x over 4y. Now, that's all my notes that I have written. But I want to explain if you chose this as your division sign instead, you would still get x divided by y over 4. Keep, change, flip. Let's see, that equals x times 4 over y, which would be 4x over y. That seems contradictory. So let me see what the book has to say. Okay, we're on 13.5. You might be saying right now, I know, Mr. Bulger, it's confusing. Okay. Well, the thing that it shows is it shows a pretty clear delineation as to which one it wants you to make the major division sign. So what we need to do here is we need to, you see how this one here is smaller than this one here? So the kind of more obvious outside one is what becomes the division sign. Yep, this is just straight from your notes. We can do this one as well. And again, we've got 1, 2, 3. So that's easy enough to remember. I'm trying to find an example that doesn't have. Oh my goodness, that's awful. Aren't you glad that we're not doing that right now? Okay, so the trick is to stay focused, like number 12 here. Ooh, and even X, or number 11. So it seems pretty obvious that it wants, for number 11, that it wants this to be the division sign, or for number 10, it wants this to be the division sign. So for number 10, it'd be x over y divided by z, which is times 1 over z, which gives us this guy. Or this, x divided by y over z. Then keep change flip, you get xz over y. All right, guys, if you have questions, let me know, and I'd be happy to go over them with you. Otherwise, love you. Bye.